Okay, so some options. This one to be. So name is DDS. Here was only you can how many frequencies you want. Right now only I want one data, that is one frequency, so I will simply choose one. Then what is the clock by which your DDS is running? This is a digital circuit, right? It will run with the clock. That clock frequency you have to mention. Okay. These options you leave. They are little hi-fi options. Right now I won't explain. SFDR it's called, spurious frequency dynamic range. And next one is called frequency resolution. These two you leave right now. Okay. The next you have to choose basically which like whatever number of channels you choose, those many numbers will come here. Actually there is only one channel, right? So one has come. Okay. And what is the output frequency? That is 0.1 megahertz. So units are megahertz, right? So I have chosen 0.1 megahertz. If your clock itself is 1 megahertz, the maximum you can generate is 0.5 megahertz, right? That's why the option is given here, valid range is 0 to 0.5 megahertz. Because the clock you mentioned to be 1 megahertz, isn't it? So any value which is 0 to 0.5 it can generate. So I have clicked here one channel, that is 0.1 megahertz. That is the input. Okay. You have to note down, you have to remember this one, 0.1 megahertz, because once your simulation output comes in your, when you are using DDC and FFT core, it is applicable. In general, you are using, let's say, DDS for your carrier generation, then simply you have to assume 0.1 megahertz you are generating. That's all. This option is only generating the frequency. Now, phase increment. Okay, if you read the theory of DDS, you will understand that by changing the delta P, that is the phase increment value, every clock cycle, you can actually change the frequency also, which is programmable. But I don't want that one. I want to be a fixed one. So I have just chosen fixed. Okay. So next. Now here also, for each channel, if you want to maintain a phase offset, what it means is, like when one channel and second channel generating, they have a phase difference that you can mention over here. I don't want any phase one, so I said none. Okay. The next, there are again some clear pins, enable pins, this, that and all. I just said, nothing is required. Pipelining, I said go for pipelining. Okay. So that the speed is improved and all. That's all. Nothing much in this are very much important. So just simply say next, then the finish option will come. So you have to click the finish. Got it. So then I'm not saying generate now because it will take some time. Datasheet also, again you can see datasheet for this one. Okay. So whatever way like that, I have this is a functional model. Same way I copy pasted this one into our top level module. Wherever you want to use a DDS core, you can copy paste. Then after declaring this as a component, okay, you can basically use it. So this is a component declaration, component DDS core. So what I did, I made the instance of it, given clock, ready for data, ready, then cosine and all that. So this cosine you can use 6-bit data. Actually that option I forgot to show. Somewhere in that one of the option it will come 6-bit, output 6 bits will come. At the end one screen was coming, right? It will show output how many bits? 6 bits. Okay. So that 6-bit data. So wherever you want to use, you can connect this signal cosine. It will generate the cos waveform. In the simulation results you will be able to see that. Even when you dump this on the board also you will be able to see that. This cosine is coming as a cos samples straight away. Okay. Frequency you have chosen 100 kHz, 0.1 megahertz. Okay. Clock, what clock you supply? 1 megahertz. If you supply 1 megahertz, it will come 100 kilohertz. Remember that. If you supply 50 megahertz, it will come 1/10. The relationship would maintain. Clock is 1 megahertz, you wanted 0.1 megahertz, so that is 1/10. If you give 50 megahertz, it will give 5 megahertz. It doesn't know, right? It will think whatever you are giving is 1 megahertz. So 1/10. That's all. Okay. You have to give exactly 1 megahertz. If you want to precisely generate 100 kilohertz, that is 0.1 megahertz. Is it clear? It's very simple to use DDS core. In our project, at least because we are generating only one cos wave. You want to
means that is sampling frequency, sir. What is 0.1?
Cos frequency andi. Cos frequency untundi kada. Cos wave. Sampling frequency is a clock. That 1 megahertz what you given a clock frequency, that is nothing but the sampling frequency of the cos. Okay. Okay. That cos frequency, cos cycle ila untundi kada. Cos frequency itself is 0.1 megahertz. Is this clear? Okay.